Hello, everyone, and welcome to another edition of Biology in the Basement with your host, Mr. Andrago. Well, thank you. And give it up to Bonesy as well. We love that guy, always helping out, the unsung hero of this whole operation. Anyways, the purpose of today's video is to talk about the immune system. I'm sure we are all very, very interested in the immune system, in that it is, of course, the topic of the day. My boys have been referring to the COVID-19 pandemic as the sickness of the day. And so I'm sure some of this information today might be helpful to you so that you can understand a little bit more about what's going on inside our bodies, inside the bodies of other people, where all of this stuff comes from in our bodies to all of a sudden gather its resources to fight off foreign invaders. And so we're going to cover all of that. I'm going to take it very slowly, step by step this week. There's a lot to break down, so I'm going to just do small chunks for you guys just to make it easier to digest. So let me give you your fact of the day so that we can get started. And that, of course, does one of my favorite things, which is to highlight females in science. And her name was Emily du Châtelet, a scientist who in 1749 feared that being pregnant at the age of 42 and having to bear a child at such an old age during the 50s, she knew that this would probably be the last thing that she did. So she worked tirelessly to make what was called the magnum opus. And of course, she worked tirelessly and finished it. And then her child was born, and she died like 2 days later. Now, some of you may be wondering, what is the magnum opus? Basically, it is the French translation and explanation of many of Newton's principles of physics. And so she was the one who helped to translate this and explain it into terms that other countries could understand. So this work is still being used in French texts 250 years later. So way to go, Emily, as your fact of the day. So fact of the day aside, we can get started with our immune system. We've got the immune system here with the function to just fight infection or inactivate foreign substances. Here's a couple more facts of the day for you. Every day you breathe in 10 to 15 million microbes. Every day, 10 to 15 million microbes are just breathed in every day, right? Why don't we have 10 to 15 million different colds? Because we have many lines of defense that help us to protect ourselves. And the odd thing is, and we haven't talked about this system yet, is that a lot of what is called immunity that you eventually achieve, you've heard that word, comes from your bone marrow. Your bone marrow is soft tissue inside of your cells that creates not only red blood cells, but white blood cells and many different kinds. There are other spots in your lymphatic system that works alongside it that you had some homework on that helps out as well. But most of your immunity comes from your bone marrow. There, of course, are different training camps and different places where these guys become specialized and have special jobs. But we will leave that to the experts with another video I'm going to share with you. So we've kind of talked about disease, right? Disease is simply the inability to maintain homeostasis, right? If you are not able to maintain homeostasis, you have a disease or a condition. Okay, now that can be usually due to genetic factors. What we're going to focus on now are diseases that come from pathogens, infectious particles. Okay? These things like viruses, right? Bacteria, fungus, other types of toxins and pollution that can be out there. So, what is a pathogen? You've probably heard that term many times. We just refer to that as a disease causing agent, meaning it can be anything that causes a sickness, a disease, or some type of disruption in your homeostasis where your cells aren't happy. They are viruses, protists, bacteria, right? Those are the big ones. But worms and fungus, those are other pathogens that can cause disease, right? Just to give you a few examples, of course, flu viruses. This is usually where I give the herpes virus fact of the day. You're familiar with those things. Bacterial infections, those are the ones that you take antibiotics for because they actually are cells, right? This isn't disease-causing organisms because, as we know, viruses are kind of on the fence. Plus, we've also got other chemicals and things in the environment that can also cause disease. But the big ones are usually the viruses, the bacteria, fungus that causes things like ringworm, yeast infections, athlete's foot, stuff like that. We can't forget protists, right? Protists cause malaria and giardia. Those are some really bad ones as well. Another important thing to think about is how these diseases are transferred, right? The whole reason that we are doing this social distancing right now is because we ourselves don't want to be a vector. In past years, I usually combine your history, global history knowledge, where you talk about the bubonic plague, right? The Black Plague that decimated Europe. And they talk about, well, how did it get from one person to the other, right? And then, you have the whole, well, it was the rats. And then there's always somebody who stands up, well, actually, the fleas on the rats were the ones that were causing this disease because it would bite the rats and it would bite the people, and blah, blah. Anyways, the point is, a vector is someone who carries a disease and then passes it on to someone else. Usually we discuss animal vectors at this point. And I have mentioned those wet markets in China in years past where people just eat things that are most likely covered in bacteria to begin with. They pull these weird salamanders and bats and stuff out of the jungle and they just throw them right down. That's not good policy. I'm just gonna say that. So this is how we get these things into our system and they disrupt homeostasis. My friend Al Myers, who works for NASA, tried to explain this to me one time, how malaria actually works with the mosquitoes and the liver and the life cycle and all of this stuff. And I stared at him with a blank face. This is some very complicated stuff. I kind of have a decent idea. I'm not going to waste my time on it, but this is just a good example of how a mosquito, right? One example where you have a bug or some kind of arthropod that can get to your skin and get to your blood, ticks included, right? And they can transmit blood from one organism to another, and in that blood is the pathogen. And so that's the big thing, right? That's why we worry about ticks. That's why we worried about mosquitoes for a while, because they're in contact with our blood and the blood of others. That's their game. So I'm going to stop there. I want to do the first line, second line, and third line of defense as one whole separate lecture. So I just wanted to cover what a pathogen was, what disease is, and how it can be transmitted. So that will cover you for this lecture. And your homework is just to do H169 and H170. Okay, so H169 and H170 is your homework. So be well, be safe. I'm thinking of you, and I'm really missing our conversations. All this human body stuff brings out a lot of cool discussions, and I just know that I'm missing out on some weird and fun conversations with you guys. So just know that this hurts a little bit for me. I don't know if that'll make you feel better or feel bad. You guys are, have mixed batch feelings about me. So, so on that note, have a good day and get your work in. All right. Signing off from Biology in the Basement, this is Mr. Andreyko.